Next, we want to use dZiner for a totally different problem, and this is essentially trying to find a likely drug molecule that has a higher binding affinity against a protein target. So before doing that, I'd like to show you the package. So this dZiner has been developed as a PPN-soluble package hosted on PyPy. I've also added documentation on how you can actually use this to your own inverse design problem. Now, we're gonna do a live demo on this. This is not pre-recorded, and we're gonna be interacting with the model, giving feedback on the design. So none of us would like to deal with pip install, which is kind of why I've integrated dZiner on Slack. This is Acceleration Consortium Slack workspace, which I will be using to interact with dZiner. Hi, dZiner. Why don't you introduce yourself to the audience? And here's a short introduction. So I'll cut to the chase, ask it for the problem that I just described to you. Thanks. I want to optimize a molecule, increase its binding affinity against WDR5 protein target. Could you help me with this task, please? And once dZiner knows about this optimization task, it's instructed to follow a set of steps. The first step is essentially doing a quick literature review on how to interact with binding affinity. So in the interest of time, I've only added one paper for this to review. This is the DOI, and these are design guidelines on how to possibly make a better molecule with a higher binding affinity against WDR5. So I'm gonna give it an initial molecule to start with and ask it to suggest 3 possible new molecules. And with this information, it will use the guidelines above and start generating molecules. Before that, it would start doing a quick assessment on the baseline that we have the initial molecule to start with. This is the visualization for the initial molecule. And we also have the docking score evaluated. So these are the 3 suggestions the model has made, and it's asking me for input. And I'm gonna tell him to go ahead and start. So looking at the initial molecule, we have a docking score of -6.5, assay score of 1.85, QED of 0.69, and this is the molecular weight. And these are the 3 changes. So based on that, it will start molecule by molecule. So for demonstration purposes, we are doing this one by one. We are working on scaling things up, but for the sequential docking score evaluation, it's going to be a little bit score, but it's going to be okay for the demonstration that we have. So this is the initial molecule that we have. The docking score has been evaluated. We're going to see a summary of this shortly. This is the second molecule based on the changes suggested here. And finally, we are going to have the third molecule. And after that, we're going to see a summary of the changes that has been made. Okay, here's the summary. From -6.5, we went to -8.6, -8.9, -8.7, and it's asking me for feedback what to do next. So looking at these molecules, looking at the docking score, kind of like the second molecule, I'm gonna use that and add some suggestions for a change. Thanks. I kind of like the second molecule. Why don't you add benzamide to the center of the molecule? And now we've asked for this change. Again, it does the same iterations, evaluate the docking score, SA and QED, and do a visualization for us. So this was minus 8.9, okay. And now from minus 8.9, we actually went to minus 9.4. Okay, great. So this is like a demonstration of the tool. In the interest of time, I'm just going to stop here, but I'll just ask the model to report back the tools it has used. Thank you. This is great. Could you report the tools that you've used? If there are any citations, also say them. Okay, so this is the paper, single paper we did rank from. We use Autodoc Vina from this paper to do prediction on docking. And yeah, thanks.